Hello bachcho, let's read this question. So the question says the heat of dissociation of gaseous water per mole at 18 degrees Celsius and 1 atmospheric pressure is 240 kilojoules. Calculate its value at 78 degrees Celsius. So water, steam or H2O gas dissociates as H2 gas plus half O2 gas, and the delta H at 18 degrees Celsius is 240 kilojoule, and the Cp at the molar heat capacity of water vapor is 33 joule Kelvin inverse mole inverse. The molar heat capacity of H2 gas is 28 joule Kelvin inverse mole inverse, and the molar heat capacity of O2 gas is 29 joule Kelvin inverse mole inverse. So here the key concept is Kirchhoff's law. So Kirchhoff's law basically क्या कहती है? It says if we have a process A giving B, so A has the enthalpy H1 and B has the enthalpy H2. So this is suppose at temperature T1. Now अगर हम उसके टेम्परेचर को इंक्रीज करते हैं, so A की टेम्परेचर को हम इंक्रीज करते हैं by some delta T, then this is A dash, and B की टेम्परेचर को हम सेम टेम्परेचर से इंक्रीज करते हैं डेल्टा T से, so this is B dash. Now we increased the temperature by delta T, so this has the enthalpy now H1 plus Cp delta T, and so Cp1 delta T because H1 की मोलर हीट कैपेसिटी और B की मोलर हीट कैपेसिटी दोनों डिफरेंट है, सो B की जो एंथैल्पी होगी दैट इज H2 plus Cp2 delta T. Alright, now at temperature T1 जो एंथैल्पी ऑफ रिएक्शन था A to B, that is delta H, which is equal to H2 minus H1. Now at temperature T2, let us say this is a higher temperature T2. So at temperature T2, the enthalpy change will be delta H2, which is equal to enthalpy of B minus enthalpy of A, that is H2 plus Cp2 delta T2, so delta T minus H1 minus Cp1 delta T. So this is equal to H2 minus H1 plus Cp2 minus Cp1 delta T. So this is, suppose this, let this be delta H1. So this is delta H1 minus delta Cp into delta T. Alright, so this is the mathematical expression for Kirchhoff's law. Now let us look at the question. यहाँ पर question में given है कि water dissociates to hydrogen and oxygen and the enthalpy change at 18 degrees Celsius is 240 kilojoules. So delta H at 18 degrees Celsius is equal to 240 kilojoules, and we are asked what is the delta H at 78 degrees Celsius. So for this we need to get the value of delta Cp, because delta H हमारे पास present है, we need to get the value of delta Cp and delta T. So delta T will be 78 degrees Celsius minus 18 degrees Celsius. यहाँ पर हम इसको केल्विन में कन्वर्ट नहीं करने, बिकॉज केल्विन में कन्वर्ट करने के लिए हमें 273 ऐड करना पड़ेगा, जो कि दोनों में ही कैंसिल हो जाएगा. सो दिस इज इक्वल टू 60 डिग्री सेल्सियस और 60 Kelvin. So we can write 60 Kelvin over here directly without writing 60 degrees Celsius. So this is 60 Kelvin, and delta Cp would be, delta Cp is equal to half into Cp of O2, because product में O2 half moles present है, so half of CpO2 plus Cp of H2 minus reactant में H2O gas present है, so Cp of H2O, and this is equal to half multiplied by 29 plus H2K 28 minus H2O 33, and this is equal to 9.5 joule Kelvin inverse mole inverse. All right, so Cp की वैल्यू मिल गई, डेल्टा टी की वैल्यू मिल गई, and this is delta H, that is 240 kilojoule, and we can write it in terms of joules, so 2,40,000 joules. So enthalpy change at 78 degrees Celsius will be enthalpy change at 18 degrees Celsius, delta H 18 plus delta Cp into delta T, that is 2,40,000 plus delta Cp कितना है 9.5 multiplied by जो temperature difference है, that is 60. So in total this is equal to 240,570 joules, or we can write it like this, 240.57 kilojoules. So this is the enthalpy change at 78 degrees Celsius. This is the required answer, and I hope you understood the concept well. Best of luck.